Vinci runs deterministic FEA solver-accurate physics simulations at manufacturing resolution, directly from native CAD. With Vinci, there's no meshing, geometry simplification, or manual cleanup. It's faster and more consistent. Let's see it in action. We'll start by creating a project and uploading a native design file. Vinci ingests common CAD EDA sources directly. In this example, we are using an open-source Xilinx package file for a 95 by 95 mm board. There's no pre-processing needed and no geometry reduction. Next, we assign material properties and confirm the stack. Layers, interfaces, and boundaries are preserved so the model matches the as-built structure. We can expand the layer gap and explore the part. Vinci can run different types of simulations. In this video, we'll demonstrate material characterizations for thermal conductivity and coefficient of thermal expansion. To begin a simulation, we'll click on the plus sign to create a new workflow and give it a name. Then assign a name for the first simulation in the workflow. Once we select the part, Vinci tiles the structure and computes effective thermal conductivity per region, with an explicit residual target to control numerical error. We'll set the number of tiles in X and Y to be 15 each. You can verify that the element resolution is around 25 microns by 25 microns. Vinci lets you select the physics setting you need: faster convergence for iteration or tighter residuals for sign-off. The underlying constraint is the same: deterministic, solver-accurate behavior. The simulation is complete. We can now explore the characterization across X, Y, and Z. For each tile, you can inspect position, conductivity, and residuals, and export the full table as a CSV for downstream analysis. This simulation shows 1.57 million degrees of freedom per tile. Each tile runs 3 simulations in X, Y, and Z direction. So 225 tiles means Vinci solved for 1.1 billion degrees of freedom in about 16 minutes. To change the type of physics on the same geometry, we'll add a new workflow in the Simulation tab. This time, we'll select a new material characterization, the coefficient of thermal expansion. Vinci tiles the structure and computes the effective coefficient of thermal expansion per region. Again, we'll set the tiles at 15 by 15, maintaining element resolution at 25 by 25 microns. We'll also set reference temperature as 25 degrees Celsius and simulation temperature as 220 degrees Celsius. Then select Start Simulation. Now we can explore the characterization of the coefficient of thermal expansion. We can analyze across volumetric or any of the axial or shear directions. For each tile, you can inspect position, coefficient of thermal expansion, thermal strain, and residuals, and export the full table as a CSV for downstream analysis. This simulation solved for 2.575 million degrees of freedom over 225 total simulations. That's about 580 million degrees of freedom in about 10 minutes. From native CAD to tiled billion DOF solutions and exportable data, Vinci gives every engineer access to physics-verified simulations at manufacturing resolution and AI speed.